Hello learners. Today our class is for B.Sc second year 4th sem physics and the paper name is optics. Okay, and today we are going to learn about the coherence and coherent sources and what are the conditions for interference of light. Okay, this is the second topic of your first unit, interference. Now, what is coherence? Okay, coherence of light or coherence means a fixed phase relationship between waves. See, let us take two waves. Let us take two waves. In these two waves, you should have a fixed phase relationship. The phase difference should be either zero or the phase difference should be some constant. Okay, the difference should be constant. Okay, or the difference can be zero. There should be no phase difference, or if it is or if at all the phase difference is there, that phase difference should be constant phase difference. Okay, or we also have the other definition which says two wave sources are perfectly coherent if they have a constant phase difference and the same frequency and the same waveform. Okay, the same thing we are learning here also. Two wave sources are perfectly coherent if they have constant phase differences, and if they are having same frequencies, they should have same frequencies, and they should have the form of the wave should be the same. Okay, now what is coherent sources? Two wave sources are said to be coherent sources if they maintain zero phase difference, or like I said, constant phase difference. Then that two waves are called as coherent waves or coherent sources. Okay, coherence, that such phenomena is called as coherence if the two waves they are maintaining zero phase difference or constant phase difference, then they are said to be coherent sources or coherent wave sources. Okay, next there are two types of source coherence: temporal coherence and spatial coherence. Okay, first one is temporal coherence, second one is spatial coherence. We'll learn about this now. Before going to temporal coherence and spatial coherence, we will see what are the conditions to get the coherent source. What are the conditions to get the better interference pattern when there are two coherent sources or two or more coherent sources. Okay, what are the conditions for the coherent sources? Okay, how we can get the sustained interference, how we can get the better fringes, and how we can get the good contrast between minima and maxima. There are some conditions to uh, fulfill these rules. Okay, so let us see what are the conditions. First condition says that coherent sources of light should be obtained from single source. Okay, if the source is there, see, suppose there are two sources S1 and S2, they are giving some coherent, they are giving coherent waves. Okay, so these two waves obtained from should be obtained from same single source of some device. Okay, that is our first condition. Next, second says that the two coherent sources must be of same frequency. Okay, same frequency, that means it should be a monochromatic light. Monochromatic light, same frequency. Okay, next, as I said, there should be phase difference of zero difference or constant. The phase difference should be zero or constant. Next, fourth point says the two sources must have same amplitude. Okay, it must have a similar amplitude. And fifth point is that it says path difference also should be very small. If there is any path difference, then that path difference also should be very small path difference. Okay, then only we'll get the sustained interference, long time interference pattern, better fringes, and good contrast between that minima and maxima. Okay, so these are the conditions for the coherent sources. Next, we'll see the types of coherences. What are the types? As I said, there are two types of coherent sources: temporal coherence and spatial coherence. Temporal coherence and spatial coherence. Okay, temporal coherence, it is also called as longitudinal coherence. So the in between these between any two waves or between any two sources, the correlation should be over time. The correlation is with respect to time. If it is with respect to time, then it is a temporal coherence. If the relation is something related to space, then it is spatial coherence. Okay, we'll see. So what is temporal coherence? See, temporal coherence refers to the correlation between the phases of waves. Phases of wave at different times. At different times. At the same point in the space. Okay, what it is saying? So when we are seeing the relation between two waves phases, okay, see, there are two waves, then we are seeing the relation between these two waves, phases between these two waves. Okay, the relation between the phases of these two waves at different times. Okay, at different times, but at the same point in the space, then they are said to be in temporal, that phenomena is temporal coherence. Like if a light source emits waves of a single frequency, then that is coherence. Okay, if a light source emits waves of single frequency, that is monochromatic light, then the phase difference should remain constant for a longer time. Okay, the phase difference should be zero between two waves. Okay, see, the phase difference is zero, or the phase difference is constant. For how much time? For a quite long time. The phase difference should be same or constant or zero. So if you are taking multiple frequencies are present in the wave, then the phase changes randomly with the time. This is the other concept. If multiple frequencies are present, then phase changes randomly. So that is why we are taking monochromatic light of single frequency. So coherence time. Now we can also see some terms here: coherence time and coherence length. The time interval over which the wave remains phase correlated. See, if the two waves are having same phase difference for particular time interval, for some time interval, that time interval is known as coherence time. Like, see, what it is saying, the time interval over which the wave remains phase correlated. The two waves should be in, the wave, if even if it is a single wave, even it is a single wave, the phase difference should be, that is, it characterizes how well a wave can interfere with itself at different times. Okay, that means it describes the correlation between the waves observed at different moments in different times. Okay, that is the coherence time and temporal coherence. Now what is coherence length? Distance over which over wave remains coherent. How much distance that those waves are in coherent. Okay, how much distance those two waves are in coherent, that distance is called as coherence length. The time interval over which the waves remains correlated is called coherence time. The distance over which the two coherent sources remains coherent, two sources remains coherent, is called as coherence distance or coherence length. Okay. Now example, we can take an ordinary bulb and a laser light. So ordinary bulb have very small coherence time, because it is not in, they'll not be correlated with the phase for a very long time. Okay, that means it has a very small coherence time, whereas laser light will have a larger coherence time. That means the phases between the laser light, the phases are correlated for a very long period of time. Okay, that is coherence. Next, so coherence time, the time interval over which, one second, the time interval over which the wave remains coherent is called as coherence time. So how much time period or how much time interval those waves are incoherent, that time interval is called as coherence time and denoted by tau or tau c. So formula for tau c is equal to 1 by delta nu. What is nu here? The spectral bandwidth, frequency. Okay. Okay. For example, a laser whose spectral bandwidth is 1 megahertz will have tau as, that means which it will have coherence time as 1 microseconds. This is just an example. As we know, time period tau is equal to 1 by frequency. That is the relation we are seeing here. Now coherence length. What is the coherence length? The distance. How much distance the two coherent or the two waves are in coherent. Till how much distance the two sources are in coherent. That distance is called as coherence length. So distance light travels during coherence time. So what is the formula for coherence length? L is equal to C into tau. So we know tau is 1 by nu. So L is equal to C into 1 by nu. Now what is this C? C is a speed of light or speed of wave here. Okay. Speed of wave or speed of light. So if the tau is 1 microseconds, then the length will be 300 meters as per the formula. Yeah, moving ahead. Spatial coherence. Okay, I hope you understood the temporal coherence. It related to the time. Okay, now spatial coherence. It is related to the space. Now let's see. Spatial coherence refers to the correlation between phases of a wave at different points in space. At different points in space. Means in which space or at what space the two waves are correlated. How they are correlated in the phase. What are the phases at particular space? Okay, what is the phase difference? What is the phase difference? What is a phase difference? How is a phase difference at particular space? That tells us spatial coherence. It is also known as transverse coherence. Okay, it tells how uniform the phase is across different points of the wavefront. If light comes from one point source, waves across the wavefront have nearly same phases. That is high spatial coherence. That means it is having high spatial coherence when they are nearly of same phase difference. Okay. If light comes from an extended source, very far source, then phases will differ and it will have a low spatial coherence. Understood? If the waves are coming from near, then there is a chance of high spatial coherence. If light is coming from an extended source, very far we can say, then the phases will differ and we can say there is a low spatial coherence. Example, laser will have high spatial coherence and sunlight, which is from far, that is extended source, it will have a low spatial coherence. Okay. So what is the importance? It's required for clear interference fringes. As I said, the condition for interference fringes are the phase difference should be 0 or constant. So that is what we are studying here. So importance is that if we require a clear interference fringes, we have to see the spatial coherence. Is it a spatial coherence or temporal coherence, like that? Okay, it is also important Young's double slit experiment, which I have explained you in the last class. Okay, Young's double slit experiment. Coherence, okay. Now differences between temporal and spatial coherence. You can see temporal coherence definition is that it's the ability of a light wave to maintain a constant phase relationship over some time. Okay, over some time period, if the waves are maintaining the same phase relation, then that is temporal coherence. Okay, if they are maintaining the phase relation, same phase relation for some space, then that is spatial coherence. Spatial coherence is the ability of a light wave to maintain a constant phase relationship across different points in space. It is temporal coherence is related to time, spatial coherence is related to space. Okay. Next, temporal coherence, phase correlation over time. Spatial coherence is over space. Temporal coherence related to frequency spread. This is related to source size. Okay. It can define the coherence length, coherence time, coherence length. It defines the coherence area. Okay, space means area. Importance in path difference, it is important in slit separation. Okay, these are the differences. Okay, by this we have completed one topic, two topics actually. One is what are the conditions to get the interference of a light, and about coherence and coherent sources. I hope you understood. You may get this question for 4 marks. Okay, so listen again and understand it properly. Thank you.